Hi, this video is to show how to use TinkerCAD to build the base for the white box prosthetic throwing arm in a way for 3D printing as opposed to using balsa wood per their instructions. So we are going to be relying on the engineering drawing or the drawing from the Outputs tab of Whitebox. This is the default drawing without any changes. Note that your dimensions are going to differ based on the your specific design. We're also going to be looking at the build and test instructions and using these to modify the design or modify the build for 3D printing. So the first thing we'll need to notice is that the stock material here is 400 millimeter by 25 millimeter by 4 millimeter thick balsa wood stock. So when we build this in TinkerCAD, we're going to be using these dimensions. So let's move over to, well, I guess we're remaining on the build instructions. So we're going to begin by making a base from this 400 millimeter stock. This turns out to be important. We know that it's also 25 millimeters thick and, 25 millimeters wide and 4 millimeters thick. So the first instruction says measure 2 of these 100 millimeter pieces, and that's going to leave, out of this 400 millimeter stock, that will leave 200 millimeters left over. All right, let's get going in TinkerCAD. So we're going to add a rectangular cube for starters, and I'm going to reduce this height to 4 millimeters. Note that millimeters will be your default when you start working in TinkerCAD. Now, if I click on one of these corners, I'll have access to the other two dimensions. So we need to make this 100 millimeters by 25. 25 is the width of that balsa wood stock, and I'll hit enter. So we know ultimately we'll need 2 of these pieces, but since we're going to be putting a hole in them, I'll wait to copy until we have that hole in place. Okay, so pieces are cut. We have our 100 millimeter pieces and our 200 millimeter piece. Now we're told to mark 25 millimeters in. This is where things are going to line up with this edge. So this hole, there's no specification given for where to put this hole, but assuming that this line leaves 25 millimeters here, if we want to center that hole up, I guess it would be 12.5 millimeters from the end to make it directly between the edge and this edge to center that. Okay, so the hole needs to be 1/4 inch, which converting to millimeters is 6.35 millimeters. Okay, and you see how these pieces assemble here. So back to TinkerCAD. We are going to want to, let's begin by just making a copy of this piece that we can then make longer. Now there's a shortcut. If I hold the Alt button and drag, that should make a copy. I can also use the basic Control-C, Control-V. Okay, so this piece is going to be, instead of 100, it's going to be 200 millimeters long. Okay, now note here, this piece doesn't fit on the grid, which is probably not any kind of problem. But if we did want to address that, we could adjust the grid. And so I guess it would just fit, but we could certainly adjust the grid to be 300 by 300 millimeters, or perhaps 300 by 200 still would have worked. Update the grid. Now we're working on a larger build space. Something that's going to help out here is if we use a top view as well as a perspective or orthographic flat view. Excuse me, we want to move off of perspective to a flat view for the purpose of lining some of these things up. Okay, back to a top view. Okay, next we're going to want to add the hole like we had discussed at 12.5 millimeters. So I'm going to drag a cylindrical hole. I like to change the number of sides to the maximum just to make these things smoother and more consistent. If I drop the number of sides down, you see things are moving a little slowly, but you'll see that this thing is essentially a polygon. There you can start to see with a number of sides at 12, you can see how rough that is, and that maximizing those sides smooths that out. Okay, now 1/4 inch, a 1/4 inch drilled hole is 6.35 millimeters. I'm going to recommend we bump that up to 7. The reason for that is that as these things 3D print and the plastic is melting, these holes often come out a little smaller than intended. Okay, so how to place this hole at exactly 12.5 millimeters. Here's a trick. We're going to use a ruler, place a ruler on one of our primary grid lines here. Notice that it's snapping to 1 millimeter, which is probably what we want at this time. With the ruler placed, if I select, whatever I select is going to show me some dimensions with the ruler. I want to zero this corner to match up with my ruler. So these dimensions in green are the distance to the corner of that piece. You see that they're now perfectly aligned with that little bullseye of my ruler here. Okay, now if I select the circle, I'm going to change the measurement to use midpoint. So instead of measuring to an end here, I'm going to measure to the midpoint. Okay, so I wanted that to be 12.5. Okay. That's going to place this exactly halfway. And now to center this up here, I could change this because this is a 25 millimeter thick piece. If I change, instead of -15 being over to the left, if I change this also to 12.5, that's now 12.5 to the center of this circle is exactly centered. Okay, might help to just see how that matches up. Okay, now if I select these two pieces and group them, I have a couple of options here. I can click on group. I like to use the shortcut Control G. Okay, so I'll just click group because I'm there. And you'll see that now makes this piece, puts the hole in the piece for me. Okay, we need as we talked about earlier, we need a copy of this piece. So let's go back to these instructions so you can follow along. This piece, you see how they match up to on the outer edge. So it's 25 millimeters between, and it's 25 millimeters to the end. And for whatever reason, they didn't show the holes from the previous steps in these pieces, but we see later that they need to be here. So how do we do this? Let's use our ruler again. We could leave it in place. We could move it. We can grab the ruler and move it around. We could leave it there and move other pieces in relation to the ruler. But let's go ahead and move this large base and zero it to the ruler. And we're going to want to get back to use endpoint, not use midpoint. So 0, 0. Okay, here we are with this corner exactly on the ruler. I think at this point we could hold the Alt button to drag a copy of this piece. We can flip these up using the rotate tool. Okay, we want to go exactly 90. If I hold the shift button, it will lock that to some of the more major rotations. Okay. There's not holding the shift button, we're on 90. Now you might see that we rotated along that axis. So here's another trick to drop these or get these back on the plane. We can move them up and down till they're how we want them. This would be one option. But the other thing, move it till it's back on the plane. The other thing we can do is just hit the D button for drop. That's a shortcut. Likewise here, D for drop. Now everything is on that plane. The last thing we'll need to do is move them into position. We could do this visually or I suppose mathematically, but we know we have 5 millimeter gradations here. 1, 2, 3, 4, 5. We know that this needs to line up exactly. So I can also just move these pieces and got a couple things going for me here. One of which is I have my 25 millimeters using the ruler. I also can count here that we are 1, 2, 3, 4, 5 times 5 millimeters or 25 millimeters. Likewise here, we can move that up until it touches, confirm that we're 25 millimeters from that point. And with the exception that I think I've placed those wrong because they're actually supposed to extend 25 millimeters out, I think we're getting pretty close here. So let's go back to a top view. Perhaps the easiest way to fix this is to grab this center piece now and just move it to 5, 10, 15, 20, 25. Okay. And that should work just as well. I am going to, the last thing I'll do is delete the ruler and select everything and group it using that group button. And we now have our base ready to be exported and put on the 3D printer.